Okay, so this is an SPSS printout of a univariate analysis, and um, the reason why we know that is simply a frequency table. Um, and so you see frequencies throughout. All right, so let's talk about how to use this printout. The first thing you'll get when you do SPSS frequency or univariate analysis is that you'll get this first table that's labeled statistics. And in this table, what I've asked for is mean, median, mode, standard deviation, range, your minimum, maximum numbers in the range, and then your percentiles, which we won't talk about percentiles this semester. And then after that, you get the actual frequency tables. That gives you your frequency, your percentage, your valid percentage, and your cumulative percentage. And it gives you your categories for the variable that you've requested, alright? Because so gender is my variable, males and females are my categories for that variable. Okay? So, then the question becomes always, what level of measurement do you have here? Gender is a variable that cannot be ranked, and because it cannot be ranked, we will call it ordinal. Okay, and so for that reason, the appropriate measures of central tendency, and let me pull this into your quick reference guide for interpretations, and these things that I'm using today are all loaded on your Blackboard site so that you can see. For nominal level measures, for univariate and interpreting univariate outputs, we would interpret the frequencies, the percentages, the mode, and then you want to say what is compelling about the data. All right. So for this formal document. For this particular document, because we know it's nominal, we know then that we'll focus on our mode, which is 1. Let me just highlight this. We'll focus on our frequencies and percentages, which are down here. Okay, frequencies. And then we will look either at our valid percent or our cumulative percent. All right. And so the reason why we don't focus on the actual percent or the percent column is because, and it's best, let me see if I can come down here and see if there's, okay. The reason why we don't focus on the percent column is that it includes missing for the most part, and you don't want to include missing data in your interpretation of your percent. So we focus on the valid percent or the cumulative percent, and I'll show you how to use those, the cumulative percents in time. So again, based on a quick interpretation guide, we'll report our frequencies, our percentages, our mode, and then we say what is compelling about the data. Okay, frequencies, percentages, mode, and what is compelling about the data. All right, so in terms of our, and you kind of do it all at one time. In other words, if you report a valid percent, then you must report the frequency that goes along with it. You don't report a percentage without a frequency. So report a percent, you got to report a frequency. The mode in this case is 1. Mode is, the definition of mode is the category that appears most often. All right, and in this case, we see that 1, which are males, appear most often, and you can see that they have more males, 1,860 males versus 1,848 females in this data. All right, so to interpret this, we might say something such as it relates to gender, males represent 50% 50% or approximately 50%, and you want to round certain numbers, and in this case percentages are what you want approximately. 50% n, small case n, is equal to 1860. Males represent approximately 50% of the sample. Okay, the modal category is 1, which represents males. Represents males. Okay. What is compelling about the data? If you look at the valid percents, and there's several ways you can interpret or try to figure out what's compelling about the data. In this case, looking at the frequencies and percentage, you'll notice that if you round 49.8 up, you get 50%. You round the valid percent down, you get 50%. So essentially, males and females represent equal, almost equal distribution in this data. Okay, so in terms of gender, well, we can say although males are the modal category, in terms of gender, females are almost equally represented in this data set. Represented in this data set. Okay? And that will be what I would consider something compelling to discuss. Okay? So we have discussed frequencies and percentages, frequencies, percentages. We've discussed the modal category and have interpreted it as it being males. We've also said what's compelling. Although males are the modal category in terms of gender, females are almost equally represented in this data set. And if you wanted to say what that number is, you can actually put n is equal to 1848 to end that out. Okay? Alright, let's go to the next one. Alright, so you got grade or year of school. I would consider this either, I would take either a interval level measure or a, well, it represents modal. I mean, ordinal, the way it's laid out, really how they have it laid out here. So that it's being ordinal, let's go back to our quick interpretation guide. It being ordinal, we interpret frequencies, percentages, median, the median, which is the middle category, and then we say what is compelling about the data. Okay, so the median, which is a measure of central tendency, represents the middle of the distribution, or the middle category of the distribution. Alright, so we come back over here and we look at the data. You have to look at the distribution. Now, there's problems, a little bit of problems with this data, because it has a 13 category that says don't attend school, and then a 14 category that says they don't know or they refuse. And so technically these things should be coded out, recoded, so that they come out of the data, so that they don't affect your overall findings. But because they weren't recoded out of the data, we're going to have to work around them. In this example, let's go back up here to our statistics and see what the median category would be, and that's a 9. Okay, so that's a 9. And then we don't use any other these other ones because of the fact that this is an ordinal level measure, and so we don't talk about measures and measure of distribution, which the rest of this is about measure of distribution. Alright, so that being said, we know from our quick interpretation guide again that we're going to do frequencies, percentages, and median. All right. And so let's go over here. The median represents 9, which is the ninth grade or freshman category. So that's the middle of the distribution. And the reason why how you can tell that even without looking at the table above is where does 50% lie? The actual frequency of 50%. And you have to look at your cumulative percent to determine that. Remember, we don't look at this guy right here. Okay, so again, we focus on our frequencies, our valid percent, our cumulative percent. In this case, our cumulative percent helps us determine where the middle of the middle of the distribution lies. So the category above that is eighth grade, is 38.6 is in the cumulative percents adds this percent 0.6 plus 5.9 plus 21.8, and then you'll get plus 16.7 over here, and you get 38.6. So if you add 21.8 plus 16.7, you'll get the 38.6. So what happens then? The 50% actually comes down here, and even though this represents 58.5%, the distance between this and this 50% is here. Okay? So therefore, without even having SPSS determine that for us, we can make that determination on our own. All right? All right, so we know that our middle of our category lies in ninth grade. The question becomes is, how do we look at this distribution? Looking at this distribution, you find that looking at the frequencies, that pretty much, and looking at the valid percents, that except for the 5th and 6th grade, there's not much difference in the distributions of the percents. All right, you see that there's very little fluctuation in the way the percents are laid out, except for on the lower ends. The 5th and 6th grade and then the 12th grade are lower. All right, so given that, it just depends on what your purpose in explaining this data. Now, this is juvenile delinquency data, and we know that delinquency peaks around the 10th grade, 10th, 11th grade, around 15, 16 years old. So that would be what, 9th, 10th grade. And so the question becomes is what is the rate or the percentages of students who are in those grades at the time. Okay, so with that said, this is how I would interpret the data. All right, I would say that in terms in terms of the distribution for grade or year in school, the median category is 9, which represents the ninth grade. All right. Also, the distribution of respondents in the categories are not much different, well, how can we say that? Categories do not fluctuate much, except on the ends of the distribution. On the end of the distribution. Okay. Given that there are more students in the ninth grade than any other grade in the distribution. N is equal to 737. Okay. Alrighty, so that's how I would interpret the data. Okay, and that's the ordinal of a measure. Alright. Age first had difficulty sleeping. Let's see. Age first had difficulty sleeping. Okay. This would be a ratio of a measure because we actually have a true zero. Alright, in the distribution. Look to see it has all numbers. Alright, and one of those numbers is a zero. So this is a ratio of a measure. Given that, let's go back to our quick reference guide. We'll interpret the mean, the standard deviation, minimum and maximum score, the distribution, and then potentially percentages and frequencies depending on how much needs to be said about the distribution. Okay? Now, the other piece about this is that you'll notice that, well, let's go back up here. The mean would be 82.41. Because we know that this is a ratio of a measure, we need to also interpret the minimum maximum scores. And you never report a mean without its standard deviation. Alright? Alright, so let me explain what these things are. Your mean is your average. Okay? That's your measure of central tendency. That is your average score. Alright? Your standard deviation says how much variation there is around your mean. Okay? Alright, how much again, how much variation there is around your mean. So you never report a mean without its standard deviation. Your minimum and maximum score is also considered a range. Now your range is reported in two types of numbers. You can report it as a single digit number or the minimum maximum score. I prefer you to report it as a minimum maximum score because it gives you a little bit more understanding of where the range starts and where it ends, right? And if you want that single digit range, then it's essentially your maximum minus your minimum score, and you get your single digit range. So if you subtract 99 from 0, you get 99, which is where that number comes from. Okay? Alright, so let's go over here and interpret our data. Now this distribution is seriously skewed. Alright, and that's because we have these two scores here. A 99, that's an unknown, that represents over half of your distribution. Almost 3,000 people are located in unknown. And then 18, it says people said who don't know are 52. So between those two numbers, it represents 3,000 and what? 48 or 3,030 something of your, which is majority of your distribution if the total is 3,708. Okay, so if you were to actually use this data, you would again have to recode these things to missing because they are seriously skewing the data. But given we have what we have, we need to, you interpret, especially on a test, you interpret what you're given. Okay, and so you go forth with that. Understand there's problems with this data. You got what you got. You interpret what you get, what you're given. All right. So the average response. The average response for age first had difficulty sleeping is 82.41, I believe. 82.41 with a is 82.41 33.41 with a standard deviation equal to 33.91, I believe. Alright, we'll have to go back and up and this means, and note that you don't just list out numbers, okay? You have to interpret your numbers. This means that the average person was unknown. Average person response to what age they first had difficulty sleeping is unknown. Okay? Is unknown. Okay? The minimum score of the distribution is 0, and the maximum score of the distribution is 99. Okay? Overall, well, what's compelling about the data? More people, majority of respondents did not know at what age they first had difficulty sleeping. Okay? Alrighty. Alright, now, what's left? I want you to do what's left. Age is left, friends delinquency. You have a computed friends delinquency, which gives you a distribution from 13 to 26, and then friends delinquency, which has been recoded to a ordinal level measure. And then what's left? And then we won't do this one because I have no idea what it is. Okay, so let's take that off. So what's left is age, friends delinquency, and then well, you tell me what level of measurement it is for the middle friends delinquency. Now, I need to tell you a little bit about this data. The distribution, the higher the number, note, the higher the number, the less delinquency committed by the respondent's friend. Okay? So in other words, 26 represents no delinquent acts. And 13 represents 13 delinquent acts committed by a friend. Okay? Alright, so you need to know that in order to be able to interpret this distribution. Alright?